Hi, my name's Nick. I'm here to talk to you about RavenDB and thinking in a document-centric world. Oh, sorry about that. There's one more. There we go. Cool. Alrighty. A lot of software problems are solved by default using relational databases. I'm going to take you on a journey for some other alternatives. Thanks for laughing. There's a wonderful place where interacting with your database doesn't have to be frustrating, doesn't have to be a pain, and there's a wizard that can help you. But remember, there's a caveat, no such thing as a silver bullet. And that was my silver bullet slide. Okay, so what is RavenDB? RavenDB is a NoSQL database. It is a document store. It's built in .NET. It's fast, easy to use, which I'll hopefully demonstrate today. That means easy to program against. And it can be summarized as sort of no impedance mismatch, .NET objects in, .NET objects out. So that's where Brownie's giving me a little bit of a squint. And that threw me. Cool. Yeah, just that's the easy to use part. So let's cover some basic NoSQL concepts first. Don't worry if I don't sell you on these yet. Hopefully it'll be more apparent later, and these can come up as questions if I don't do a good explanation. So, CAP theorem. CAP theorem is consistency, availability when there's a partition. If your database has a network component, and when you suffer a network partition between your data stores, you get to have this slider. You get to decide what your focus is, consistency or availability. Sorry, not either or, some slider across. And this is not just limited to NoSQL databases, but it's easier. It's something easier to control with NoSQL databases. Sorry, when my mouse moves. Okay. The next thing, documents. Raven is a document store. Documents are not flat. A single document can be complex. This also means that it's no longer a challenge to store your data, but this does not mean chaos. You still need to spend time thinking about how you structure your documents. The next fundamental is eventual consistency. And I'll focus this around how it works in Raven. In Raven, writes occur against a document store. So I have a document that I'm going to write. Let's say it's product inventory. I write it in the document store. That write operation will happen asynchronously without slowing down anything else. Other parts of my application that may be at the same time querying against what's referred to as the index store that represents the data that's in the database will, as a result, perform well, not get interrupted by this. Now, Raven is more consistent than others. At this point, if I was to do a load action against Raven, and I knew the ID of the document I just inserted, I would get it back. That part would be instantaneous. It wouldn't be waiting for an index update. I've got a little note there, but I don't want to touch on that unless someone's got a question. So to summarize that, we're optimizing for reading by doing this, and we're prioritizing availability over consistency. Alrighty, so how do you actually use Raven? Well, all you have to do is download it, go through a 4 or 5 step installation, step wizard, and you're done, and it's running locally. The production deploy is almost as easy, and we can talk about that offline if anyone's interested. Just another note, I've got the little GitHub screen there. It's open source. If you want to see how any of this is done, which some of our dev team finds useful, you can just go and have a look in the source code. The next part is how you actually interact with Raven. Every database, every database has some kind of management studio. So this is my first demo. So let's see how we go. Okay, so this is one of the only negatives against RavenDB is you need Silverlight installed. And the Management Studio, so to navigate to this, once you've installed it, it's installed it on your local IIS under port 8080. You will spend quite often reloading this page. But once you're in and it is working, things are good. I have a bunch of databases there. You can see it's slowly coming up with statistics about how much data is in them. If I was to make a new database, sorry, that's a new document. If I was to make a new database, all I do is click new and I give it a name. Hello, guys. I'll quickly touch on some of the things here. Just briefly, Raven's this screen. I haven't rehearsed that, so I'll just tell you about it. I don't want to muck things up. There's just a bunch of bundles. The two I want to briefly mention is compression and encryption, and another one is SQL replication bundle. So there's a nice way inside Raven to funnel data out to those who don't want to give up your relational databases for whatever reasons you have. Hello guys is the name of it. We click next, and it's saying creating databases, and it worked. Clap for that, because sometimes it doesn't work. Thank you. Okay, so you can start populating this database now with a new document. I'm not good at typing up here. So basically, documents are just JSON. You can start filling this out, but this is not how you start interacting with your database. You're going to start doing it with code. So let's jump back. Okay. And there was a screenshot if that failed. So there's what a populated database looks like. It tells you all the different documents. You have a different little view slider that lets you sort of, it's almost like a thumbnail preview size of your document. You can collapse it to a details view. You can increase it to a large preview where you actually see inside the documents. So other than some occasional hiccups in the Silverlight Studio, just often get solved by hard refreshing or opening it in another tab. It's actually quite good, and if it falls over in terms of what you're trying to do, there's always an export to CSV option when you want to sort of pull some data out for looking at if the IDE is sort of slowing you down. IDE is slowing you down. Okay, so that's the Management Studio. Now it's about using it in your .NET code. So how do you get started with this? NuGet. Anything, if it's not on NuGet, it doesn't exist. Just do a search for RavenDB and you'll see RavenDB client. Another little note here, there is an embedded model of this where you can actually, I haven't actually tried it, but basically runs Raven in process. You don't have to do that installation step. But I feel doing that installation step is quite easy, and just have a local copy running in. And actually, sorry, I missed, it runs as a, you can install it as a Windows service or you can install it in IIS if you want to do that. I suggest installing it as a Windows service, because it's nice to be able to just go and reset it that way through your Services tab in Task Manager. Okay, so you've got your NuGet package, and now you've basically got what's the equivalent of an ORM for interacting with Raven. I'll touch on Session in a second, but Session is basically, is anyone not familiar with something like an Hibernate or Entity Framework? Not familiar with? You can put your hand up. Okay, so yeah. The session is most similar to what's the Hibernate session. I don't know too much about Entity Framework and its object context. So, up a new class, session.store. Same way for load. You tell it the type of document you want to load and the ID in which you stored it against. And queries are just link. So this is fantastic. And I'll dig more into querying soon. Okay. It follows the unit of work pattern, just like Hibernate. Yeah. So you open a session, make changes in memory to the document, and the changes get persisted. I'm just going to briefly touch on this. The search capabilities underlying Raven is Lucene. If you haven't heard of Lucene, look it up. It's a very powerful full text style search with lots of capabilities. It's its own talk. So just inside Raven, you can fall back down into the full capabilities of Lucene for your advanced querying. Okay, So how do we do our regular fetching and querying straight out of Raven using it like a ORM? So I already showed you the load. The first thing I want to touch on is include. This is the equivalent of joins, but much better. So forget about joins. Session.include. Sorry. So we saw before session.load. Well, this is the document we're loading. In this case, it's a job document. What we're doing is we're also including as part of that load a user document. And that assigned user ID is on this document. So this document simply stores an ID. You could consider that the equivalent of your foreign key, but no referential integrity. So it's more flexible. What this does is in one round trip fetches your document plus the user. And then that last line is just using AutoMapper to map this document to a DTO, just something simplified. So there's also querying, quite similar, Session.Query. This time I'm going to query for multiple of these job documents, and I'm going to give it my where clause, which is link. And here I've introduced skip and take, which is very nice to use as well. Skipping on page number multiplied by a results page, and we're going to take. So skip and take just works. It's nice. That goes straight to Raven, gets you your exact page size that you want. Let's combine those two things now, the query plus include. Let me know if I'm losing you. And I'll look for hands. Session.customize, you'll see here, it's not that different. These are just this is just how you interact with Raven. You'll see the friendly thing I just introduced you to was the C include, and I've repeated it 3 times so you can't miss it. But we'll do a customize call for job documents, and this time it links out to 3 other document areas, 3 other collections of documents. The user, something called a file, and something called a brief. Now, I pass in my standard where clause, and I toList. This thing will return me, basically, all job documents, and lazily load each of these and bring it to me in one request. Okay, so I just issued the equivalent of select star from against my job documents. Don't do that. But Raven is safe by default. There's 3 magic numbers. First, default page size. That query I just executed will not return me the million records we have in our jobs table because our customers are very busy with jobs. The default page size is 128. That where clause gave me 128 results, and I think it did it quietly. It didn't error, just, hey, you didn't tell me how to cap the results. Allende made the decision that 128 was good enough. Now, you can obviously override that with a larger skip and take. I could go skip 0, take 1,000,000. I'm crazy, give me my data. Allende says, no, don't do that. Maybe you mucked up the value you had in the take. Allende says, stop at 1024. And here, is this quiet as well, or do you get an exception? No, you don't get an exception. This is quiet as well. So it goes, I think you went too far with your take, all right? With all of these, you can override them if you really want, but this is nice. This is nice when you make a mistake. Okay. The third magic number is 30. 30 requests. Raven here will tell you, what are you doing? You just, in one session, asked me 30 times for something. Are you sure you know what you're doing? And the answer probably is no. Okay, so I'll jump back a slide now. On this Session.Query, if I had left off the first one, the assigned user ID, and then further down in my processing of this, tried to operate on those, Raven's going to go, hey, I didn't get those for you. Let me go get them for you. Now, I just did a toList. This is going to result in 128 results. On the 30th round trip in that 128 collection, you'll get an exception. Hey, you've just hit me 30 times. I think you're doing something wrong. All right? Now, sorry, I didn't get the chance to finalize my Fiddler demo, but basically, and I'll touch on this a bit more later, but Fiddler is your friend. You can spin up Fiddler, which is a HTTP proxy profiling analysis tool, and you will see these requests screaming by. And this will help you find the one that was to blame. Now remember, Raven doesn't know what you're doing. It's just telling you on the 30th request. You may have had 3 well-crafted queries. The first one did 1 round trip. The second one did 29. The third one pushed you over the limit. And that's the one that's going to exception. So there's a little tip. That's something that we've discovered the other day. You're trying to debug that last one and you go, no, it's fine. This query, it works. You're lying to me. No, it was the one it was some other one in the chain. I'll stop on that. We found that bug. Okay. Next awesome thing about Raven, transformers. Forget everything you know about stored procedures. I hope no one's using them. These are server-side projections with document loading, okay? Really want to harp on this. This .NET code that I wrote here, this link statement, runs inside Raven, all right? I ran it, we deployed it, I coded in .NET, wrote unit integration tests, whatever I like, syntax highlighting, everything compilation. We deployed it to Raven. Now I'm fetching these documents again. In this case, it's part of the other document. And I'm telling it, hey, with the result set, use this transformer. And I'll show you the transformer on the next slide. And then you do your regular things, skip, take, status, and you return them. So the key here is transform with. This is my transformer. Sorry, the transformer is what is running inside Raven. And this is the DTO that it's going to produce. So here's a simple transformer. All you see it's doing is it's selecting the exact subset. So our query performs well. This is exactly what comes out of Raven for this. Now, I was hesitant to put these in because the feedback was, oh, that's a lot of code on a screen. But bear with me. I wanted to see how this goes with real world examples. So this is our real code for this transformer. I'm pretty sure it didn't change today. So, and this note is for me as much as it is for you. There's a job, and a job has different parts called a brief. This is important because this transformer is the job transformer. And I underlined the part so I wouldn't forget as well. But that's that's a nested transformer that I'm going to call. So transform the nested thing, and this is where we call it. And this just happens to be the syntax for Raven. This is how you invoke the nested transformer. And we've got some resharper notes there as well. But basically, I'm doing the exact same things you saw in that other query. I'm getting the users here. You see I'm loading documents users. I'm getting those nested things. I've got my load there. And I've got my other load, the user. We just happen to have 2 types of users in this one with 2 classifications. And then slightly bigger, the thing that I'm returning. So it's the simple transformer plus that, plus that, plus that. So, and then that last bit of syntax is just how you do it inside Raven. Here is the nested transformer. It's also roughly 30 lines of code, but there's nothing special about it. It's just a lot of properties, and it just happens to reach out as well and load some extra documents. So we're doing exactly what we're fetching everything we need to deliver this to the UI, and only just that. And then there's just some extra little things that happen there. Just again telling Raven how to operate on this. Alrighty, next concept is indexes. So remember at the start I mentioned there's you write against the document store, and then there's sort of the indexes. Yeah, so with the power of a schemaless NoSQL database comes some responsibility. Raven does not know about the fields on your documents by default. When you start querying Raven, it's going to make dynamic queries, just like a relational database will. The advice is, don't let it do that. Make your own indexes, have them fine-tuned. It's not tricky, and this is another bit of .NET code that you write that gets deployed. All you have to do to create an index is extend from abstract index creation task. So you extend from some kind of Raven concept, some class, and you tell it. And in this case, sorry for switching paradigms, but in this case we've got projects. And projects just have a title and a job number. And I tell Raven, hey, I want an index called projects by job number and title. and then you tell it what to index on, title and a job number, and this is just the Raven syntax. That's it. It's that simple. Now, the next powerful thing about indexes is mapping, what you just saw, and reducing. Now, all reducing examples are very simple, but I have two varieties of reducers to talk about. In this case, we're going to take those project documents. So again, we're extending the abstract index creation task, the project document, and this time I've got this nice little DTO. The DTO has job number and count. What we're going to do is we're going to map job numbers, and we're going to get each job number a count. And then, just like your regular aggregation that you do in SQL or anywhere else, we're going to group by the job number. And what we're going to get is the sum operation of that count. So for every job number, I'm going to know how many projects reference it. That's it. That's a map reduce. And that's actually how we use them. This is not a real one, but we have basically the equivalent of a real one we're going to write tomorrow for one particular feature. The next part of indexes is multi-map. You're not limited to mapping documents of the same type. Okay? The way you would do this in a relational database like SQL, you would use unions. Who's ever used a union to join non-same types of things? Was it fun? All right. There's a better way. So, no need for all those types of joins. Here's a real multi-map from our code base. Basically, like you saw before, extend that, add a map. We're mapping users, we're mapping groups, and we're mapping organizations. And we're selecting out part of them to give them a display name and a type. And our index is called security object index. It's a term that makes sense to us. They give you little security objects. And then we tell Raven, hey, store these fields and analyze these fields, because it hasn't heard of these before. So it's made a new index for us. And now with one single query against our document store, we can fetch out, we can do a search in a single text box to let us add a user or a group or an organization or a fourth concept I left off here and assign that to the job or the project. So that's the power of these multi-maps. I'm not going to go into this code, but here's our real world example of a abstract multi-map index creation task that is a multi-map reduce function that does recursive reduction to build a permission tree index, basically. There's a little bit of a performance bug here. There's a prize for whoever spots it. I didn't update the slide. We've already fixed it. Alrighty. So I touched briefly on profiling. Profiling is first class. Like Allende built this. Allende built NH Profiler for Hibernate. He knows what he's doing. Fiddler is your friend. I'm conscious of time, so if you haven't seen Fiddler, look it up, download it, install it. You just see HTTP requests against your database. You double click on them, you'll see the exact, your get URL or your post will be there. You'll see exactly what's hitting the database. You cannot achieve the level of profiling awesomeness with a relational database. I haven't seen it, all right? Unless you are really good with Wireshark. One guy laughs. From my team. Yeah. The next one, also I'll skip the demo, but if anyone's interested, there's lots of videos around on this. And this is just for your standard ASP.NET MVC apps. Profiling is really nice as well. All you have to do is install another package, add 2 lines of code, initialize the Raven profiler using this is the package, and you give it the document store, however you're doing that, and I'll get back to that in a second. And somewhere top level, introduce this, the Razor syntax, for doing our current request session. So has anyone used, what's it called? Sorry?
Mini Profiler.
Yeah, like Mini Profiler, and there was another one. It's just like that. So in the UI on your regular page, you'll get this little yellow section that's come from that line, and it's captured what you've done, what you've issued against Raven. So you can drill into these. You'll see the get calls. They'll bring up little modules that shows you the URL path. We don't use this. That's why I struggled to get the demo running. I was having some NuGet NuGet store issues last night, so I couldn't finalize it. But this is it, and yeah, so you'll see the timings, you'll see all that. It's basically profiling within your browser, within the app. So technically you could deploy this to production or one of your pre-production environments and achieve that.
Did you have to instrument your code with using statements to get the measurements in?
What do you mean? Oh, no. So yeah, so this is the injection point in your app. And this is something you'll call in your global ASAX. So top level, like application start. And then this is where it actually takes a hold inside your the pages that get rendered.
So it actually intercepts the calls without any further coding.
Yeah, that's it. And there's other tools there's other things that do this as well. Cool. So we haven't had that many questions yet either. So I was hoping that some of these real world examples would drive some questions as well. Sorry. No? I thought it was desperate for questions. All right. How are we using it at Picnic? Our data in goes through an event store. Some projection logic happens. That's what gets persisted. The outcome of that gets persisted into Raven, and then different parts of our app fetch data out. This is very high level. There's much more moving parts. Now, this is more reflective of the title of my talk. The structure of our documents is some of our best lessons learned. The major lessons learned are transformers are great, indexes are great. We discovered indexes well before transformers. I'll touch on that as well. So, yeah, the way we're using it, I could summarize it into 3 types of documents. The first, that's specific to our app domain, is network of documents. In this case, these documents are all quite small. They roughly have under 15 properties, and they just happen to point to some other little documents that represent just files. So in this case, we've got a shirt. A shirt document points to 2 photos of that same shirt, front and back. We've got a shorts document. It points to 3 shots of the shorts, front, back, side. And this is specific to our domain, when the shorts were photographed, they had a model wearing the shorts and that shirt. All we have to do is point our shirt document at that as well. And sorry, I was just trying to fit these on the slide. This is not some hierarchy. They're all equal. They're all reasonably equal peers. So this document gets shared across that. And then our transformers and our indexes help fetch what we want. So one of our largest transformers is about this, but all it does is piece these things together in a nice way, because this is a little bit different to that, and sometimes these are hanging off on their own. And both of them point to this one shared document, which is the logo. So that was the brand of the shorts and the shirt were both the same brand. Single documents are also popular in our app. These are large documents that look like this when they're in Raven. In this scenario, basically, for a given part of our application, it made the most sense that none of the parts of this made sense on their own. So we just started building a larger document that, for the most part, we deliver in the query, because on that single user interface, we're not expecting them to get large. If they do, we'll target that. But basically, for the most part, the repeating part of this, which you might consider to split out into different documents, is something we call revisions. So it's almost like that job and that job component one. All of those little pieces end up here, and we needed to switch through them. This was like almost like a version control for parts of a document. So the different photos taken of those shorts, but basically this made the most sense for storing a single document that matched how we operated on the data in the UI and how the users used it. The third variety is more standalone. So it's part of that network diagram, but they don't really spread any further. And these were the jobs that I was talking about before. Basically, a job has one or several other components. For a little while, we had a 4th type, and these were something we referred to as summary documents. This was another lesson learned for us. This was before we knew about transformers. We started to store separate documents that were that little, like, you remember that little transformer I showed you that gave me the exact data I needed? We thought we needed that level of summary from some of these larger documents. We found, and the information was basically, storage is cheap, let's just store more documents that are well shaped. Well, we realized, no, we didn't need to. It became a pain to keep them up to date. And we actually had some weird bugs where a particular set of events would modify the larger real representation of the document, and the summary would have to catch up or, you know, get the wrong IDs because we weren't doing ID allocation at the right time. So we abandoned that, and we replaced those with transformers and summary DTOs. And I did a quick code search. We don't have any summary documents left, so I'm not lying. Okay, so I alluded to this earlier, but when you write your indexes and your transformers, you get to deploy them inside Raven. The deployment is very simple. I was thinking about how you would deploy a whole bunch of stored procedures. You have to do a whole heap of things, usually. I don't know if anyone's got a really nice way of deploying lots of stored procedures. Oh, there are tools. But for us, deploying our indexes and transformers is simply a matter of reflection. So we tell it the assembly that's got these that are coded in, and then this is a Raven mechanism, index creation. Hey, take this assembly for this database, apply these. And the last line there is some conventions, and I'll go to those in the next slide. The other part of this is that I alluded to was how you get the document session. This is the same for any kind of thing. It's just managing connection strings and dealing with an IOC container. In this case, it's AutoFact for us. Whoops. Oh, damn it. Yeah. Couch is not good.
That's all right. Nothing's going to catch fire.
Yeah. Pretty sure. Sorry about that. Yeah, this is just some registration code. If you're really interested in this, we can go over it later. The only thing I wanted to point to here was line 92. Sorry, I was also lazy in starting all the numbers from 1. But I wanted line numbers. We just have some replication stuff here as well. But I didn't want to get too much into that. That can be an offline chat if anyone's interested. The other part of this is the document conventions. We happen to use nice, strongly typed identifiers for each of our documents. So the job and the project ID are their own types. We can't get them mixed up. They're just GUIDs. We just have to do some manual. This in the real file, it's as long as all the documents we have. Yeah, and then that's what issues the IDs. No, we do it in this case. Yeah, we're using GUIDs in this case. Yeah, so this is a little bit of legacy left over from us from how we did something similar to this. At the time, we were using an Hibernate Comb GUIDs generation. We realized we didn't need to. This just works fine.
Is there any way of enforcing uniqueness? I mean, are you just hoping that the GUIDs are unique?
They will be unique. Yeah.
But,
they will. I can guarantee you they will be unique. Unless someone's doing something like copy pasting strings, they'll be unique.
Don't you guys have a folder for GUID?
Yeah, and we've got that too. So we've got a binder where we print out the ones that we've used. So there's and they're published as well. So like it's all out in the clear.
on Twitter?
Twitter as well.
For non-public IDs, where you can't give a client a GUID.
Yes.
This is your GUID, and you give them client number 1 million.
Yes.
Can you enforce uniqueness with those?
Just repeat the question, Nick.
Sorry. So the question is, if you don't have the confidence to generate, or you cannot generate the IDs, and you want to enforce uniqueness, how do you do it? We don't. Brownie?
Raven has built-in high-low, so it'll manage that for you, and so you get basically unique integers.
Okay.
Yeah.
You're going to repeat that.
So the answer is RavenDB has high-low built in. It will generate the IDs for you. So yeah, on that part, it's very on par with relational databases in terms of capabilities. Yes. Thanks, Brownie. Why did I have this up here? Projectors. Oh yes, our projectors from our diagram. I just wanted to briefly share this to continue the rest of the real-world example. From our event sourcing, our events come in. IOC helps us deliver the documents. with some information from our aggregates. We load the document. So for our most trivial things where we're doing updates, the document is here. Our methods are very straightforward. We change the properties we want. Bam, we're done. Our most complicated examples are where we're newing something up. So in this case, it's the created event. I'll be careful not to knock more things over. Yeah, we do some newing up things. We get some information from the event context, you know, like when this actually happened, because we don't trust that data arriving, things like that. Who did it? Set up some security stuff, and that's it. Like, our projector logic to interact with Raven is very simple, and I already showed you our reading data out of Raven. Those were very simple as well. None of the queries exceed a few lines when you factor in the where, the skip and the take and the to list, and our transformers were roughly 30 lines on average. Our biggest one is less than 70. Great. So, some more information up there. It's a little bit out of date now, but still a lot of the stuff is very relevant. The Pluralsight course, the Raven docs are quite good for the most part, unless you're doing some really tricky things. And there's a RavenDB high performance book by Brian Ritchie. Got 70% of the way through that, so yeah, there's some interesting stuff there. Cool. Thank you. Yes?
With indexes, if you let RavenDB automatically create indexes, or it does that in the background, is there any way to know which of those indexes are and let it flush them out again because you're no longer using them, or are they permanent?
Oh, you'll definitely see them. So in the management studio, I can show you that quickly.
It'll flush them.
Yeah.
You can flush them.
You can? Yeah, you can go into the management studio and just delete them as well, and you can see what it's actually done as well, if you like. Sorry, I should close some of my tabs. And the projector's on the left. So, for that, you would go to indexes, you would select a database that has them. Someone help me out. How far down? Tennis blue. This is what they look like when they're in a Raven Management Studio.
The second one's an auto one.
The second one's an auto one. Yeah, it's prefixed with auto. If we want to edit it, we'll see what it does. It's folder documents, and it's just fetching out the folder ID and the doc name. Do we get any more statistics on this? No. That's it. And yeah, you could delete it here. I don't know what the lock does. Change lock. Yeah, you could just delete them here.
Okay, follow on from that then. When it creates indexes, is there a way to force it to use some form of sharding?
So when it creates...
Those indexes at all? Because in the scenario I'm at, I use OData queries against an API and have shards. People making queries into the database, one customer on one shard making a query, a complex query against their data, and somebody else maybe using a completely different query against their data on their shard. But we don't want those indexes to cross each other, get in each other's way. But we'd like the index to be created on the shard. Does Raven do that?
Yes. All right. Let me repeat the question. So you've got different customers, and you want different indexes per customer, and you mentioned sharding. Or in that your scenario, yes, there's sharding.
People understand it's a unique collection of data that
yeah.
So
my recommendation would be, as we do, that's why you saw a lot of databases there. We have a database per customer, and you can have a database per shard. Customers, sorry, how many?
Yeah, 20,000.
20,000.
So I don't want to be going down that path. I'm trying to stop going down all that database weirdness path and going to sharding.
That's... Well, are you going to have 20,000... If you've got 20,000 customers, would you have 20,000 indexes?
It depends, you see, because each one has a possibility to do their own unique queries using OData against the API, so I can't control what queries they make.
Well, you get to name...
Common ones.
Yeah, you get to name your indexes. Yeah, you get to name your indexes, so you would... in your case, I would name the most dominant indexes.
Yeah.
You know, customer A, B, C, and D. Yeah, and you would deploy those and use those. So then your code would need to know. Your code would be responsible for the switching. Yeah, that's an interesting problem. Yeah. No, we haven't seen anything like that, have we?
So you can actually include security information in the underlying receiving document. and you can drop down to that and start with that as your base query and then drop back up to link.
Okay. Yeah,
So there
that
is
sort
some
of
stuff
sounds
like that.
Like I could tinker with.
Okay, so the answer for the microphone is Lucene can help you out with that part.
I'll do
If I'd be interested to know if 20,000, especially if you're doing sharding, I would still I believe we still possibly would have gone down the 20,000 database approach with Raven.
Yeah.
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 And that's a big if. I don't know more about your domain. Yeah, that's interesting.
Does Raven choose to use index, the best one, or do you have to specify an index?
Does Raven choose the best index, or you have to specify one? Definitely don't have too many indexes. It will, yeah, I'm pretty sure it'll match on the one that's most relevant based on your where.
Or you can specify.
Or you can specify it, yeah. Same way you saw me specifying the transformer, you could tell it, hey, use this index. So that's where you would solve your problem of, if you had the multiple indexes, you'd have your logic switching up there to tell you, hey, you know, for our top 5 customers, use this index, for the others, use this, or things like that, in a nice giant C# switch statement. Or inject in the right transformers as some kind of dependency as well. Actually, yeah, that might be better. Maybe. It's a big number. Cool. Yes?
So how do you manage schema changes for your documents?
It's not a problem. So, it's schema-less. So we haven't had to do major changes yet. The documents are forgiving, basically. That's JSON. If there's a property there, I can go into any of our documents. I could log into our production servers now, just add fields to the documents. Nothing will happen. If nothing's asking for that data back, there won't be a problem. If something's trying to put the data in and it knows about it, that's fine. So it's a broader, bigger problem about what that schema change means to you. There is...
If the code is not forgiving, how do you manage that?
No, the code will be, because you're going to give it a type. So with the, depending on your serialization settings, for the most part, but the defaults are forgiving. If something's not missing out of Raven, it just won't map it. Sorry, if there's an addition there, which is going to be a problem, a different field. Yeah. So possibly the trickiest one would be a changing of a field. The way we're solving that, and we'll be solving that, is through reprojecting our data. We would basically, and the rest of our architecture supports this, we would basically delete those documents and just project our events back into Raven with the changes. If you couldn't do that, there is something called Patch API in Raven. If you're using, the recommendation is if you're using Patch through a lot of your code, you're possibly doing something wrong. Step back, look at your code. If this is a rarer occurrence, you can issue Patch API queries against Raven to do the change for you. So basically you do that the same way you would do any kind of schema change. You take down or pause other parts of your app, do it, deploy new code that matches the schema change you just did, and business as usual. Yeah, so either or option would work. Any more questions? Yes?
Does it do any sort of compression? Like, let's say you've got a schema, or you've got
Yep.
a lot of documents with the same fields. Can it store it like more like a column store database and actually compress?
I don't know, I haven't dug into the compression stuff. I did touch on that there is the compression bundle. All I know is, just like with all compression or encryption, you have to have turned it on from the start. All right, otherwise it just won't work. I do believe so. Sorry. Yeah, I can look that up. No, I haven't. Has anyone heard about the compression in Raven? No, we haven't looked into it. It is. I wonder if he'd be doing. I'm guessing he wouldn't be doing anything by default, because obviously compression takes some kind of performance hit.
Yeah, there's been talks on doing, like, shortening the field names, but he said it's more trouble than it's worth.
Yeah, so I'd be interested to hear about the particular problem as well. If you've got such a large volume of data, that compression is of concern as well.
Well, you could keep more in memory. The more it's compressed,
Yeah.
the less
Yeah, interesting. I think there'd be easier solutions than trying to compress your database for keeping things in memory. And maybe the next talk will help with that. Cool. Yes?
Can you back yourself?
Yes. And you can restore, which is even better. So we spent the last 2-3 weeks building a disaster recovery strategy. Yeah. For Raven, our event store, everything. We are backing up Raven just out of paranoia. But for us, Raven is something we can blow away and reproject to. So yeah, just in case everything else falls down in the disaster recovery plan, basically do the copy things. And don't ask me questions on this, but we do master replication in Raven. Yeah, so that's our other that's our other strategy. Cool. Yeah.
How do you actually monitor Raven from a sysops perspective?
Good question. What's the question is, how do you monitor Raven from a sysops perspective? Riemann, help us out with that a little bit.
So there's a whole bunch of API calls you can do to get stats out of Raven. I mean, obviously it's in Studio as well.
Yeah.
You can actually just do like curl requests or whatever, and you get a whole bunch of stats, like a JSON document full of like how much indexing is going on, a whole bunch of memory usage stats, like all that kind of stuff.
Yeah, so it's treat Raven as a little web service that you can just issue commands against, and yeah, there is a suite of these. So we have yeah, we're probing different parts of our infrastructure in some kind of a little a single screen aggregator. So as an example, typically we're probing the machines that they're running on. So we were probing the 2 instances that were running the RavenDBs, and we noticed some CPU issues and we noticed some memory issues as well. And so that allowed us to target those. I'm sure there's other stats you can do, yeah, on the fly.
The last couple of questions, Nick, and then we'll
Sure, because we're hitting 46. Sorry, there was one more. Yes?
What are the main advantages and disadvantages of this kind of document storing, especially using Raven?
Yeah, okay. So they're very, very easy to use. We switched over we were using Nhibernate on a Friday. On the Monday, we were using Raven. All right? By the next Friday, we had moved all of our .NET, all of our data persistence logic out of Nhibernate. And our previous switch before that was switching away from SQL Server to MySQL. That was a cost decision. Nhibernate made that easy. On that Friday, I was having a bad day with Nhibernate. It just wouldn't let me map the things I wanted to map with Fluent Nhibernate. And we were already talking about Raven. I spent the week, not much of the weekend, getting up some of the conventions about our IDs and what it took to install it. Brownie took over on Monday. A few of us jumped on, we ported all our stuff, and we dished MySQL and Nhibernate, and don't plan to look back. We had a different part of our app, we were storing data in a different way. That took a little bit more of a refactor, but that's in Raven as well. And the answer to that part is we're actually using Lucene, slightly incorrectly, as a data store. Yeah, and that's all in Raven as well. So that's a whole nother conversation as well. I think that's it. Yeah. Chat to me after if you've got any more questions. Cool. Thank you.